Hi all, this video is about Pythagoras and his theorem. So Pythagoras lived about 2,000 years ago, and he came up with a very important theorem based on right-angle triangles, and this only works with right-angle triangles. And you can actually prove that a triangle is a right-angle triangle by seeing if Pythagoras' theorem works on it. So I've got my right-angle triangle here, and it's important to label the sides. I'm going to label them A, B and C because that's normally how we label them. Now make sure your C is the longer side, what we call the hypotenuse. Here, hypotenuse. Now you can find the hypotenuse by just seeing which is the longer side, or it's always the side opposite the right angle, so you can always find it in one of those two ways. So Pythagoras said that a squared plus b squared equals c squared. So if you square this length here and then add it to the square of this length, you get the square of this length here. So there's lots of different proofs as to why that works. I'm not going to go into that now, but you can find them on the internet if you want to know exactly where that came from. Let's do a couple of examples to see if we have got the hang of this. So I'm going to start with a right angle triangle here. That's not a very straight line. I'll try that one again. Okay, right. Right angle triangle. Let's say this length is 6, this length is 8, and I want to find out this length. And the question might be, find x. So what you can do is label them A, B and C, but it's important, as we said, that this one, the hypotenuse, is C. The A and the B don't really matter. So I start by writing Pythagoras' theorem, and I substitute in the numbers. So I know that A is 6, it's going to be 6 squared, plus B is 8, 8 squared, and C, well, I could call it C, but it's probably best to call it X, because that's what it is in the question. So I work this out using, well, you can use a calculator, but these are quite easy numbers you can do in your head. 36 plus 64 is x squared. So that's 100 is x squared. Some people like flipping it around now, but you don't have to. X squared is 100. Now to get rid of the squared, we need to take the square root. So x is the square root of 100. So that works out to be 10. And the units here, well, I haven't said on the question. Normally they'll say something like centimeters or meters. So you add your units here, 10 centimeters. Okay, that's the easier version. That's when you're finding out the hypotenuse. Questions can ask you to find out other lengths. For example, something like this. We'll have our right angle triangle here. We'll call this length 11 centimeters. This can be, say, 13 centimeters. And we want to find out x. So again, I label my triangle. My hypotenuse is always C. And your A and your B don't really matter, so just do A and B. So I start with writing out Pythagoras' theorem, as always. A squared plus B squared equals C squared. And my A was 11, so that's 11 squared. B is x, that's x squared. And C is 13, that's 13 squared. Okay, so 11 squared is 121, plus x squared is 13 squared is 169. Now, I can't just take the square root here because this x squared has this 121 on the same side as it. So we need to get rid of this 121. So we need to minus 121. We need to minus it on both sides to make it fair because it is an equation. So if I take away 121 from this side, I'm left with x squared. And take away 121 from this side, I'll have 169 minus 121. So that's x squared equals 148. Now here you can take the square root of 148 to find out what x is. And you may struggle to do this in your head because it's not a perfect square number. So you'd be allowed to use a calculator to work out the square root of 148. If it comes up on your calculator display as 2 root 37, you need to press SD, and it'll give it to you in decimal form, which is 12.16552506. I would write the whole thing down and then round it to something sensible. So I would say 1 decimal place is sensible, so that's 12 point, and then this 6 will make the 1 round up, so 12.2 centimeters. Finally, just check to see if that makes sense. Is that length about 12? Or look at the diagram. Yep, that looks about right. It's got to be less than this 13. So 12.2 looks about right, so you can be confident that you've got that one correct. Okay, just move this out of the way and I'll give you a couple to try, and then you can pause the video and give them a go. So if we have a square here, and I'll make the sides 7 centimeters each, I'd like you please to find the length of the diagonal. You can pause the video now. Okay, let's see how we got on. So this is a square with a right angle here, and essentially we've got a right angle triangle here, kind of hidden within the square. So I hope you figured that out. And opposite the right angle must be the C, the hypotenuse, and the A and the B don't really matter. So after writing out Pythagoras' theorem, we can say 7 squared plus 7 squared equals c squared. So this is 49 plus 49 is c squared. So that's 98 equals c squared. So c will be the square root of 98. And then you'll need a calculator for this. You can tell it's going to be just a little bit underneath 10. And I would say that is 9.9 centimeters to 1 decimal place. So well done if you got that one. Okay, and I'll give you one more of this slightly trickier version. So another right angle triangle, because Pythagoras only works, remember, with right angle triangles. We can say this is 6 meters, and this can be 4 meters. I'd like you to find x, please. You can go ahead and pause the video. Okay, let's see how you did. So after writing Pythagoras' theorem and labeling the sides, we have 4 squared plus x squared equals 6 squared. So that's 16 plus x squared is 36. Now to get this x squared on its own, we need to take away the 36. So I take away the 16. So that's x squared equals 20. And x equals the square root of 20. And with your calculator to 1 decimal place, square root of 20 is 4.5. And we're talking about meters here, so 4.5 meters. Check with your diagram. Yeah, 4.5 meters is reasonable. So that's the answer. Well done if you got that. Okay, that's all from this video. Bye.